Okay, for the first discussion, talk about what is your favorite crime documentary or podcast, including something like Serial, Making of a Murderer, The Jinx, Thin Blue Line, Other, etc. What is interesting about this to you or the people that you're talking to if you're having conversations, and try to relate this interest to psychology and cognition. Okay, so the point of this discussion, it doesn't exactly fit in with things. I just wanted you talking and kind of just stimulate your mind and get going this morning. So how we all doing today? Good, okay, goodish. Tired still? The rain, yeah, it's quite rainy. What do you guys think about this prompt? What's your favorite documentary podcast?
Definitely Making a Murderer.
Yeah, you liked it?
It frustrates me. It makes me really mad.
Okay, what's frustrating about it to you?
Because I don't know if Stephen Avery did it. I can't say for sure because the documentary was very biased, obviously. But I know that Brendan should not be in prison for life. He does not have even the cognitive ability to be able to commit this murder. And he kept giving details that were not real. There was no DNA evidence to back it up. There was no blood. Everything he was saying was wrong because they questioned him without counsel. He was 16 and they questioned him without his parent present. Literally, and it just makes me mad.
Totally. I think he's legally below the threshold.
He is.
He's legally retarded.
And they were but that's okay.
Yeah.
No worries. He can still understand. No, he can't.
So it's kind of that corruption or that what can a person be held responsible for?
And they appealed it all the way up to the Supreme Court and they didn't do anything about it.
Mm-hmm. Another interesting thing, you guys know that Scalia, Justice Scalia of the Supreme Court passed away. Okay, so current events, right? Nice. Anybody else? Anything else we have to talk about?
Mine wasn't up there, but I watched a documentary it was a TV show series. It was called Dangerous Women. And
Okay.
This one particular episode was beyond crazy. This lady pretended to be pregnant for 9 months. She would stuff her shirt, slept next to her husband. Husband thought she was pregnant. She would go out and pretend that she was going to the doctors. He never went with her, but assumed that she was going. But she joined a Facebook group with other moms who were the same path that she was on. And she went to meet one of them to talk about toys and their children could be friends. She ends up going over to the house, killing her, cutting the baby out, and taking it home. And she's like, honey, I had a birth today, you missed it. And he's like, oh, that's great, honey. Totally missed it, totally doesn't why didn't you call me or anything?
Mm-hmm.
Then she didn't clean up the crime scene, so they found out that her DNA was all over it, and then they arrest her, and they're like, that's not your child. And the husband's like, oh, I had no idea. And they interviewed him, they're like, how'd you not know your wife was pregnant? You sleep next to her. Oh, I don't know. I didn't think she would lie about it. It was crazy.
That sounds crazy.
I actually watched that the news report on that when it happened. It's nuts.
Isn't that nuts? It's shocking too, right? That we're all kind of these normal people, maybe and something goes wrong, and then.
That's why it's interesting. The second part of the question. It's interesting
to you?
Because you want to know what compels someone to do that and why they think that way, and you don't. So that whole abnormal psychology aspect.
Yeah, I think that's probably, how many of you got into psychology because you're curious about abnormal type stuff? Yeah, a good amount of you. I think it's what sort of sparks those ideas, right? Has anybody seen The Jinx? Anybody? No, you should check it out. It's really, really good. Mm-hmm.
Is that the one with just recently, the guy admitted on a hot mic in the bathroom?
Yes,
Okay.
that's the one.
I told you.
He was a wealthy New York real estate, his family owned just a bunch of properties. So he's very wealthy, and his wife went missing. It was a cold case, and then crazy stuff started to kick up, and he's not convicted of any of it, and he agrees to be interviewed by a man that made a film about his wife's disappearance. So it was kind of a bad move on his part, but a very interesting documentary.
Was that Gone Girl that you just said, or no?
No, that's a really good.
Is that a real story?
No, that's a fiction.
Okay.
Who's seen Gone Girl? It's really good. It was All Pretty Things or something like that. It's on Netflix. You could check it out. All Good Things. That's what the film about the true crime, about the guy that's in the Jinx, is basically. But yeah, just wanted to get your minds going. A little bit of fun for you. Okay, so you all finished the first exam. Here is the distribution. So there was one question that was just, it was wrong, the answer that was written in. So it was the modal model. So if you guys checked that out, I think every single person got it right. So you would have an increase in one. And then another question I thought was poorly worded. So it was what is let me check it out. The question about, why can't I think of the word right now? We'll go to it. What do you guys think, looking at your scores? Anybody? Happy, sad? In the middle? Okay.
Could do better, but it was just the first exam, so usually it's the lowest grade.
Absolutely, it's the first exam. So let's just look at it real quick. And then I'll show you the grades again.
So did the grades adjusted on Blackboard then?
Yes, it's adjusted now. Oh, come on. Falsification. Okay, so what was the falsification principle? This one might have seemed like it was poorly worded to you because, I mean, I didn't end up liking it. So the correct answer was, what is the falsification principle, or what does it state? So it's basically a strategy so you can rule out poor hypotheses. Basically, if there's no way you could possibly prove your hypothesis incorrectly, then it's a flawed experimental design, because in science we want to come up with conclusive answers. So I think a good amount of you went with, it is impossible to find positive evidence for the existence of an effect, which is just kind of gobbledygook. It's not exactly correct. It's just a nothing answer, but it kind of makes sense. So I think the question wasn't written all that well, my fault. So everybody got full credit for that one. So extra points.
There's this one question, and it says, how are neurons called that code one specific type of information?
It would be like what?
Yeah, but that one I got wrong, and I did not understand.
Okay, good. Let me take a quick look. I'm gonna just see what the statistics are really quick. So I'm gonna. This is good. I want you guys to think about the fairness of questions, because I want the class to be fair for you. So. Orientation. Did anybody else have specific questions that they didn't like?
Is there any way to go back and see the exam?
Yeah, you should be able to. Was anybody able to successfully do that? And on my end, it works. Okay.
You get wrong, but you can't see the right answer.
Oh, you still can't?
You can't see the right answers, but you can see that you it says 0 out of 10 points if you miss the question.
Okay, I will fix that so that you can all see what's going on. Let me run this again. So Blackboard's got some interesting features. You can analyze your specific questions in an exam. So I'm just playing around with that, see what we can do. to make sure you can see what's going on. Here's the distribution for this question. The correct answer, how are neurons called that code one specific type of information, e.g. orientation? Feature units was the correct answer. It looks like we do have a lot of consensus towards that. So at this point, I'm going to let it stand, but we're going to see as exams continue if we need to curve them. We'll make sure that that's fair for everybody. What was that?
I said she was supposed to give me points. And you didn't.
I tried. I would like the points too for that question.
Yeah. So I pay attention to the distribution of things. I mean, all I can do is try to make things fair within reason, or I get in trouble too. But here's the distribution of grades. The mean was an 81%, which is a B. There were 10 of you that got A's, 19 B's, then drops off from there. So if you weren't very successful at this exam, just pay attention to the formatting of it, what you thought was working for you or not. What I would specifically say that would be helpful is make sure you're downloading the PowerPoints, you're writing your notes on that. For me, if I ever have an online exam, something that I really like to do, just even to come back to a topic or review it, if you go to a PowerPoint and you just do Control F or Command F in your Mac, then you can find any term and then it'll automatically bring you to that page and you can take a look. There's also your book and you can look at terms in the back of the book to bring you to the correct information.
Are the rest of the exams going to be online as well, or are they going to be in class?
They're all online. What do we think about online?
It's okay, but I thought it was a little bit difficult.
It was a little difficult.
Just a little bit.
Yeah, it has to be a little difficult because you have open notes, right? So that's kind of the trade-off, is if you're in class, then I can make sure nobody has notes open, and then I can just give you pure memorization things. But if it's at home, some of you are going to be really good at finding correct answers just without knowing information prior. It looked like the average amount of time was about an hour and a half. Do you think that's correct for you? Is that about how much time you spent on it? Okay. Okay, good to know. We will keep going as planned. If, for any other exams, we'll just make sure that the average is high. If I need to curve, I will. For this exam, we're not going to curve it yet. Let me just see how things play out as the rest of the semester unfolds. Remember that your lowest exam grade will get dropped. So, yep, just keep on plugging away. Do your best. And remember, you can still get extra credit by doing SONA. So,
I have a question about that.
mhm.
So when I went to click on our
That's the
class,
one
our
thing.
section number wasn't on there.
Okay. Yeah, let me play with that. I'll have to figure that out. But as long as you're doing SONA, just remember, like, on the site, you should be able to keep your credit. You should be able to see, like, what you still did. So you can just email me, and we'll make sure that it all works out.
We went online, the class wouldn't even pop up.
When you go online, you have to click on a class to register for it,
Mhm.
and since our class isn't there, we can't see the studies that are going on.
Okay. Then I definitely need to check that out. I will do that today. One more question?
I'm sure I can talk about this after, but if I'm doing studies outside just for whatever, can I still apply that to this class
It has to go through our SONA system.
through your sort of section?
It doesn't have to be like mine specifically, or I guess. You can't double apply, so you can only do it one time for whatever class. But yeah, let me know if, like, are you saying that you're volunteering like another organization or?
Well, I'm volunteering just for like I think one for participation and money, so that's not one for the class. That's just for whatever.
Okay.
So, I don't know because that's not on the SOTA system yet. It's just
So the point of like allowing people to do extra credit on SONA is just so that we get more participants sort of in our system. So that's more of what it, I guess, applies for. So. But good question. We have more questions? Anything going on here? What's up? How are we doing? Where? You're pointing at me. What's going on?
Oh, no.
I mean, anything that you want to talk about? Oh, yeah.
I just asked them if they asked you how, or if they talked to you about how hard the test was.
How hard it was?
And they said no, they didn't. So I called them slackers.
Did we think so? We thought it was pretty hard?
Yeah, it was pretty.
Okay, what was hard about it? Let's talk about that. Or did you? Let's go. Yeah, okay.
I don't know if I thought it was like difficult, but there were some questions. I read them and I thought it had nothing to do with psych. I don't remember which questions specifically, but I remember reading it and reading the answers and just being like, when did we talk about this or where is this in our PowerPoints, and having no idea what it was.
Okay, well, make sure you're writing those down. I mean, I draw from what's going on. Some of it's going to be more verbally discussed in class, and it's going to be discussed more thoroughly in your book. But yeah, I mean, make sure that you're documenting, and then we can talk about it.
Like there were a few questions that were like really specific, and I felt like it was like I felt like that was because it was like online or whatever.
Yeah.
But like I felt like it should have been like a little more conceptual. Not that I'm like complaining about my grade, but like.
No, I mean, that's good to bring that up. I mean, again, there's so much information that we're learning, like, throughout this class, that what you're seeing online, 28 questions, doesn't cover a lot, so maybe they'll be in depth, but it's basically, like, you should learn a lot of this stuff, broadly, and be able to pick out little pieces of information.
The only problem I had was like some of them, when I would go to like do like the control find on like the PowerPoint, the word that I was looking for would be there, but like it wouldn't have anything to do with like the question that I was like being asked.
Okay.
So that was my only thing. Like I thought it was like
It wasn't
the questions
referencing
were pretty
right.
fair, but like it wasn't referencing specifically, and then I would have to look in the book, and then like it wasn't in the book where I was looking, and so that was my only thing. Like when I would look for specifically what it was asking, I couldn't find that.
Okay, that's
Like, I
good.
could
That's good to
find,
bring that up.
Like what we were talking about, but I couldn't find specifically what the question was asking.
Okay, good point.
Does that make sense?
It does make sense, yeah. I mean, make sure that we're like taking notes and writing things down. Again, like I'm structuring my class off of what's been done in the past, but this is the first time I've taught it as well. So you are totally probably right that there are things that we don't discuss as thoroughly in class that are somewhat in what's presented to me, but it's maybe presented differently to you. So it's good to keep that in mind. How do we all feel? What if instead of 81%, what if I just curved it to 85%? Is that going to help us a little bit? Are we happy about that? Okay. Okay, you got it. Yep.
One thing, the dates that you were using in there, a lot of times it looked like you were trying for a trick question because the dates were not right.
Okay. It's
So
kind of
you would have
around.
a year for a study, and the book had a different year by like 6 years off type thing.
Okay, let's take a look at that.
Those were the dates.
You felt like it was totally different. I mean, those were directly copied from
There was one-
previous
there was a-
exams.
There was a study in the book said 1953 and the question said 1959 or something like that. I mean, it just made it look like a trick question.
Yeah, understandable.
So what was the class average?
The class average was 81, so we'll curve it to 85. There were 10 A's, 19 B's. Is that right? Yeah. So far, there were 10 A's, 19 B's, 7 or 8 or 9 C's. Okay. So we'll just go ahead and curve it. You talked me into it. You proud of yourselves?
Yeah. I don't want to feel like we're bullying you into doing that.
No, I mean, that's fine. My job is to make you learn, but also like feeling like your work is rewarded helps you learn too. So that's good. Okay. I'm glad we're all kind of on the same page, trying to make it fair, hopefully make it better next time.
I have a question.
Sure.
There was a question on the class about Ebbinghaus's experiment.
savings curve or the forgetting curve was either 2 hours or 6 days, but I was looking at the book and it said it was specifically 2 days. So I just want to know the answer to that one.
Oh, I think that was sort of there are sometimes random answers that don't correspond to specific things, so just make sure you're picking out
The best,
yeah, exactly. Yeah, I remember that. I think I wrote that question. Okay. So if you have more specific things you want to talk about, you can come see me at some point. We'll just go ahead and get started. I want to cover just the rest of our last thing. I was going to post a video, but it was only 10 slides. So we'll just cover that in class and then move on. And we'll cover as much as we can of short-term memory and working memory today. And then we have Thursday for the same thing too. So we were talking about attention last week, and we ended on this slide actually. So it's sort of, we're talking about in our visual system, what we're paying attention to. It's broken down into the things that stand out to us, so the salient messages. So as you can see, like from the butterfly moving downwards, we've got this saliency map. So it's sort of decomposed in that the bluer colors are less salient and the more red or darker colors are going to stick out to you. That's what's most salient about the scene. You can see in the top one, we've got mostly green, and then the butterfly itself is orange, so it's got a lot of contrast. There's dark lines around the wings, so those types of things stand out to us. In the person map, you can definitely see that the eyes and the outline of sort of her physical body are standing out to us. A lot of that's also going to be that that eyes are very important to us. So typically when you're looking at images of people, we can track this with like an eye tracker, or it's actually seeing how your eyes move around a screen. We pay attention to the eyes pretty quickly, so eyes stand out to us pretty easily in most scenes. But it's not just about saliency, so the things that are sticking out at you the most. There are things that will override that initial effect. So your task demands, if you know what you're going to do next, those will cause you to focus on different things in a scene. So this is a study where people were asked to make a peanut butter and jelly sandwich, and before they actually engaged in the task itself, their eye movements scrolled across the scene in the order that a person would achieve that, creating the sandwich. So it wasn't just the features like red jelly that was standing out, but it was actually looking from item to item in the order that you would make the sandwich before actually making the sandwich. So eye movements preceding the action to reveal the action goals. If you were looking at an eye tracker, so you're actually seeing where the eyes move, you could see a person's goals or what a person is paying attention to based off of where their eyes move. And attention can be shifted without eye movement. So this is a covert shift in attention. A couple slides back, you'll see those definitions. But your eyes can focus on things and you can be paying attention to something else, so it can be a little deceptive. So here is a study with inattentional blindness. So participants looked at this fixation cross and they had to judge what line was longer. I mean, it's a neutral fixation cross, or it might be like slightly different. But in one of the trials, they were flashed a shape, but they weren't paying attention to the shape. They were still focused on the which line is longer task. And then later when they're asked to recognize what the shape was, they couldn't do it. So while it was still in their field of vision, actually they could see from an eye tracker that they did focus on the shape for a few seconds or microseconds. They still weren't able to consciously say what object they did see. So you can be looking at something directly and not paying attention to it, not remembering it, which is interesting. There's also, so this is a spatial cueing. Cueing is a really interesting way to see people's like attention, or how you can manipulate their attention. So in this study, you see a fixation cross, and then the next slide, you see a arrow that's supposed to cue you or tell you where to focus your attention. Then you see the fixation cross again, and then you'll see the actual target in the picture, and then you have to respond what side it showed up on. So if you cue them with an arrow, so it's basically telling you, look over this way. Not intentionally, or not, a person doesn't intentionally focus their attention that way, they're just cued, like they are given information from the scene that sets them up to do something unconsciously. So, but basically you get this effect. If I tell you to look over here with an arrow and that it comes to the other side, you're slower to respond. But if I'm pointing you that direction and it's there, you're quicker to respond. So it's the cueing effect, a gaze cueing effect. And from physiological studies, we put electrodes in monkeys' heads. They had a cueing experiment. So basically the takeaway message is when they had a light flashing on the side of the screen, the monkey's paying attention to the dot in the middle, you do get more activation, and that's really happening in the parietal lobe. So basically your attentional shifts are occurring in the parietal lobe. That's the takeaway message from this. So there are also different things that we're learning from kind of these cues and how our minds put things together. So there's the location-based attention, so that's the arrows. So it's telling you, it's highlighting a specific spatial location, but then there's also an effect of just sort of those Gestalt like grouping phenomena. So here's an experiment where participants were cued where to focus their attention by this little box around these two rectangles. And so they had the cue on, cue off, and then the target's presented. And if you're accurately cued to where the target is, then you'll respond faster. So it can occur in either this top left or top right or bottom right. And what they found is if you're cued on the top right, you'll get the cueing effect even if it's on the bottom right. So basically you're grouping this entire right rectangle and you get the cueing effect even if it's not in the correct position. There's something about our understanding of that underlying shape or the clustering of information that can still, make us pay attention to that object. So instead of the location cueing you where to look exactly, it's pay attention to this object. What's on this object? So it's kind of interesting. So something that actually we do in our lab is the effect of like social cueing. So basically, like I said, eyes convey a lot of information. In that experiment with the gaze cueing and the arrow, it's basically saying, hey, participant, look, focus your attention on this, even though you're not actually focusing your eyes. It's a covert attentional shift. In the same experiment, or a variation of this experiment, instead of the arrow, you see a face, either a real face or just a cartoon face, or what we do is robot faces. And then the face will switch its line of sight to one direction or another, and if it's looking in the direction where the target appears, you'll be faster. If it's looking in the direction that the target does not appear, you'll be slower. So you get sort of this idea of how sensitive people are to that social information, the eye direction. And it's interesting that people with somewhere on the autism spectrum are not as good at this task, which is kind of strange. Because you think like we're all sort of learning or seeing the same social information, but along the autism spectrum, people aren't picking up or learning specifically a lot of what we inherently learn, how to focus our social attention. There's a slide or there's a picture in your book. It's not on the slides itself, but if you see a scene and you're using this sort of eye tracker, like people will focus their attention on where the individual in the picture is looking, for instance, or the individual's eyes, that kind of thing. Whereas people on the autism spectrum aren't paying attention to the same things, just don't. Paying attention to random salient things in the environment instead of what we're cued to perceive in our social minds. So just in summary of all of the information from chapter 4, selective attention. Selective attention is our ability to focus on one feature while ignoring all others, or sometimes a few features. Models of selective attention can be distinguished based on when the selection itself takes place. So you remember that kind of model with the attenuator, or take a look at the slides, you'll be able to see these things. Early selection models propose that the attended message is separated entirely from the incoming signal early on in your, when the information is actually sensed by you, so everything else is filtered out immediately. Intermediate selection model proposes that later separation, so that the separation of the messages occur sort of later on in the process, and it explains how the unattended messages can sometimes get through, like the cocktail party effect. Somebody calls your name in the background, you're not consciously paying attention, but that, you know, alerts you to what's going on. This late selection model proposes that selection does not officially occur until messages are preceded enough to determine what their meaning is, so that dictionary unit. That's actually more cocktail party stuff. And the ability to selectively attend is affected by task load and expertise with that type of task. So as you learn, you can pay attention to other things, like if you're driving, that task, if you're an expert, has become fairly easy for you. So if you see a ball rolling along the road, you'll know to stop, or you'll be able to use more attentional resources to complete other tasks. But never text and drive, right? And then in divided attention is possible for easy tasks or highly practiced difficult tasks. But in these situations, automatic processing is possible, whereas in divided attention is not possible for very demanding tasks or tasks that you find demanding, which require a lot of your controlling resources, controlled processing. The Stroop effect we kind of looked at is an example where your automatic processing decreases your performance. So we're likely to read the word without intentionally wanting to read the word when you're supposed to look at the color of the word. The word itself just pops in your mind and it becomes difficult for you to accurately complete the task. Driver inattention is one of the major causes of automobile accidents. In visual, eye movements are a basic mechanism for determining attention to different parts of the visual scene. In the overt state, when you're actually paying attention to the thing that your eyes are looking at. There's the bottom-up processing is the saliency of whatever you're paying attention to, and the top-down process would be what you know you're supposed to be doing with the scene. So like making the peanut butter and jelly. You know you're supposed to be attending to certain things, so it's not just the bottom-up saliency that's affecting your eye movements and what you're paying attention to. Visual attention can be directed to different places in a scene, even without eye movements. So that's covert attention, when you're paying attention to something, even though your eyes are looking at something else. And you can measure it with this cueing effect, where you're not actually focusing on the information that's presented to your left or your right, but reaction time is still changing based off of the cues. And location-based attention is when attention is shifted to a spatial location. Object-based attention occurs when attention is directed towards a specific object, not just the location. And following gaze is called social attention and is impaired in people with autism. And that's it. Any questions on this? Mm-hmm.
Can you go back to the spatial cueing slide?
Yeah. Went too far. Yep. Spatial. This one? Okay. Do you need me to talk about it a little bit more? So it's like telling you to look in a location. Like I'm telling you with the arrow to look to the right side. Even though your eyes aren't actually moving to the right side, you're told to still focus on that arrow. But it's cueing you to be biased towards a part of the screen. Okay. Right? Whereas the object-based, this is a great question. It's kind of explaining it a little bit more. Whereas the object-based, so we've got these two rectangles. It's not just telling you where on the screen to look, because you've got the up left, up right, bottom right. But if you're seeing something on the upper right or the bottom right, you still have a better reaction time to the A or the B. So it's basically like you have that location, but you also have the shape itself, and the shape itself is what's making you better at the task. So focus on the one on the right.
So it's all based on like a cue, like somebody telling you to, okay.
These experiments, yes. So it's these are still your covert attention. So your eyes aren't necessarily moving to these specific things, but you know something's flashing and telling you pay attention to whatever. Yeah, great question. Cool. Anything else? A lot of this was covered last week, so you can go back and watch that video if you need to as well. And we will go ahead and move on. To Chapter 5, Working Memory and Short-Term Memory. So, memory is one of the most important things one of the most important aspects that we have as people. Makes sense, right? We have this present interaction, what's happening right now in this moment that's, so fast that we're not really processing all of it. But we have identities, we remember ourselves, we remember our past. It's sort of this idea that we have a time machine, or we have this wealth of knowledge to draw from, but in a real physical sense, all of that information's done with. We've seen those signals, they are gone, they've moved on and done whatever, but our mind still retains some representation of that allows us to still think about the information, still keep the relevant aspects of that. What is memory, as we're talking about today, and we're talking about the beginning stages of that. We've got chapters 6 and 7 to talk more about memory, but memory is the processes involved in retaining, retrieving, and using information. Information about the stimuli we're presented with, which might be images, the events, the ideas, the sound, the skills that we're using, etc. And this process, memory, occurs after the original information is presented to you and is now gone from the scene. So you have that representation, even though the physical environment still doesn't present you with that same stimulation. What do we use memory for? Basically everything. Right now you're listening to messages that are coming out of my mouth. I'm remembering the information that I read from your book in order to convey the information to you. Sentences occur on a time course. I can say a sentence to you and you'll remember the beginning and the end of that sentence fairly well and be able to interpret the meaning as we move along. So what is the purpose of memory? So we retain information that is no longer present in the environment. We remember that it's rainy outside right now, even though we're in this room and we're not entirely sure of what's happening outside. You can use it as your little time machine, so you're traveling back in time, seconds, years, so you can re-experience the events of your life, happy or sad, and the feelings that are associated with that. We call that episodic memory, so sort of the episodes of your life. You can remember facts that we've learned, so we're still learning. So that's sort of memory of the facts, called semantic memory. We can also remember what we plan for our future, the pertinent things that are going to affect us in the short term and the long term. You have your career goals, your life goals. This is your prospective memory, so the prospects of your life. And we can use the skills that we've acquired over time in order to aid us in our tasks, etc. That's procedural memory. So your book talks about this man. It's a case study. So Clive Waring he experienced damage to his temporal lobe because of this viral encephalitis, like I think it's water in the brain, basically like swelling incident causing damage. So since his temporal lobe was damaged, he had an inability to form memories. So he couldn't remember what was going on past like a few seconds or a few minutes. 2 minutes. So he couldn't, so he would live within the most recent 1 or 2 minutes of his life. He couldn't remember what had just happened to him beyond that time scale. He forgot everything else. And basically he feels like his life has become, every second of his life he's becoming conscious for the first time again. So this is terrible for him. He describes it as being, feeling like death, like every moment is like his life feels like death. So he had to write down specifically what he'd been doing just to try to, if you write down this message, maybe it'll help you. Like our memories, sort of written down messages for us to access. So if you have to offload that into, at the time they didn't even have computers, so in a notebook, you can imagine that would be very difficult. He wrote things like, I awoke for the first time, I am alive, I just woke up, that kind of thing. So it's sort of haunting even, just the idea that you don't have access to that wealth of information of who you were as a person, that you can't grow or really achieve new experiences that enlighten you, make you feel like the person you are. So not good, and it makes you sort of appreciate sort of the ability to remember, the ability to have that time machine, right? Who appreciates their memory on a daily basis? Cool, okay, good. That's really it. Yeah, and it's important that we think our memories are infallible as well. You've probably learned about false memories, those types of phenomena. Memory is good and memory is not perfect, but it's better than having no memory and having to keep a notebook. So what we'll really talk about through this Chapter 5 overview, return to the modal model of cognition. So what are the stages within that modal model? We'll talk about short-term memory. What are the properties of short-term memory? Working memory, sort of a later proposed idea that interacts as kind of the same idea as short-term memory. There's discussions there. How does working memory explain short-term memory processes? So it's a little more involved. And what does the brain hold, or how does the brain hold information within your working memory? Which I don't think we'll get to today. So if we return to this modal model, you'll remember that we have all of our sensory input coming into us all of the time, constantly, everything you're seeing, everything you're feeling and hearing, your brain is encompassing, like all of those signals come in, but we can only pay attention to a small amount of them. That small amount of information that you're attending to is fed to your short-term memory. There's an interplay between your short-term memory and your long-term memory to be able to focus on your task, to understand what to do with that information, eventually leading to the output of your decision or your final thought, your final expression. But now we're introducing this idea of something that's going on within this short-term memory process. So we'll talk about an example that involves rehearsal, so basically saying something over and over to yourself so you're keeping it in your short-term memory a little bit longer. This is called a control process. So sensory memory, the initial stage that holds all the incoming information for seconds or a fraction of a second. We'll look at some experiments that deal with that sensory memory stage. Your short-term memory can hold somewhere between 5 and 9, so kind of the number is 7 plus or minus 2 items for about 15 to 30 seconds, some experiments with that. And then long-term memory we won't get to today, but long-term memory can hold large amounts of information for many years, hypothetically forever. You might just lose the ability to reference that information, for instance.
So it's strictly 15 to 30 seconds, which is considered short-term memory. So whatever happened this morning is, let's say 7 a.m., is technically long-term.
Yeah, if you can remember what's going on, or that you remember what happened in your 7 a.m. Yeah, you might lose sort of your reference to it as it becomes less important for you, but yes, it's transferred into your long-term memory. And it's not strict, it's about 15 to 30 seconds, and people have done experiments to sort of flesh that out, so that's sort of the normal case. What people normally can hold within that short-term memory is 5 to 9 pieces of information for 15 to 30 seconds, if you're not converting it into that long-term memory. Good question. Does that sort of make sense to people? And we'll talk more about that in like the long-term memory chapters as well.
I have a question about the Clive Warren thing. Was his procedural memory impacted too?
I think so. It's talking about it more in your book.
Okay.
But I think what it illustrates is more of his inability to have long-term memory. So it's more anecdotal. I'm sure you can get more into the details looking more into his case. But another good question. Okay. So this control process is that new stage, that new little loop that was added onto the modal model. So that control process is an active processes that can be controlled by the person themselves, is sort of an aid in keeping things in your short-term memory to be able to work with them. It may differ from one task to another. Some common examples are rehearsal. We'll go through a anecdotal example of that. So when you repeat information over and over again to yourself in your mind or out loud to help you remember it, there are different memory strategies. You can, like if you're remembering an acronym for whatever thing and you apply like a silly sentence to it so it sticks in your mind better, do you know what I mean? Like, yeah. Like my very eager mother just served us 9 pizzas. Do you guys remember that for like the planets? That type of thing. There's some interesting work. There's a really interesting TED talk about people who have these memory palaces. Who's ever heard of a memory palace? Yeah? Just heard of it, okay. It's cool. It's a really cool strategy. It's basically people who train their minds to remember information very accurately, very impressively by thinking of their experience as if they had a mansion in their mind. So in the mansion in your mind, whatever thing you're trying to remember, this control process, you relate it to physical things that are in your mansion. So there's a TED talk, and somebody's supposed to be remembering numbers or a process. So he says as soon as he walks in the door of his memory palace, he sees Cookie Monster doing something specifically. So it's like a silly strategy that ends up like, since that's sort of abnormal, that idea, it sticks in your mind a little bit longer. It's sort of more memorable. So there are some really interesting examples of that make you remember things for a long time. And attention strategies, so things to make you focus your attention on what to remember, for instance, like highlighting your book. I will post that TED Talk because I think it's really cool, and I butchered the example basically, but there are like competitions for how many things a person can remember at one time. And it's basically a strategy of coming up with silly things to help you remember pieces of information.
Are there different like variations of that strategy? Because I know that like my psych professor last semester, when we were going over memory, there was a list that we all created of like all these like grocery items, and he himself remembered all of them because he like related each item to a task that he does every single day.
Absolutely. That's a strategy for. You can also, we'll talk, I think it's at least in your book, about chunking things differently. So if you have to remember like a list of things, you could put them in a certain order that makes them, instead of 5 things, 1 sentence of things. So it's, strategies to help you remember.
Is photographic memory like a real thing?
Yes, there are people that have photographic memory. I don't know what specifically is involved in that, but it is cool. I think a lot of musicians do. I've heard that before. So it's like just really helpful if you can take a picture in your mind of like the music you have to follow along with. It's pretty rare, but pretty cool, right? Me too. It'd be really nice. You could just like take a mental picture of a page in your book, and then it'll help you on an exam.
I think I had heard that eidetic and photographic memory, they have a tendency towards dementia and Alzheimer's later in life.
Oh, yeah.
Because I have photographic memory.
Sorry.
Watch out.
Photographic memory. And my grandpa has Alzheimer's. So I'm like, oh.
There seems to be a correlation.
That is interesting. I mean, that's one of the things we're working on, though, clinically, I think, is trying to combat Alzheimer's. So hopefully it won't ever affect you. Did you have a comment?
Oh, no, I was just saying that I have photographic memory.
Oh.
But my issue is sometimes I can see it, but I can't see the answer. Like, the answer would be blurred out. Like, it's like a waste of a talent.
Maybe you can hone it and really become like a superhero with your photographic memory abilities. I'm into it. If any of you have like superpowers, you should totally become superheroes. Not just vigilantes, but like, legit like heroes. Just silly. Who's into Marvel? Right? We all kind of like, are you getting a little sick of all of it though? Like there's just so much stuff, right? I didn't see Deadpool.
It's so good.
Oh, awesome. I definitely will.
So fantastic.
Cool. I'm glad that we like these things. Yeah, I was having a conversation about that the other day. It's basically like when you have a strategy, when you have a formula for making a lot of money on things, where superhero movies have kind of become that. And I've heard Deadpool breaks the mold, so that's kind of nice. Okay.
I used to date this guy who knew all about it, and that's why now I know a little more about it, where I wasn't into it before. But it's annoying that it gets to a point where it all loops back on itself. So, I mean, that's gets annoying.
Within the story, or you mean?
Yeah, for example, this is obviously not Marvel, but for Superman, he gets so powerful that they have to kill him off and then start over.
Yeah.
I don't know.
Because they have to keep that story going to keep fans interested too. Tangent. So here's an example. Let's make it a little more interesting. So you are a superhero, or you're, let's say, just like a loose, you're a cop playing Fast and Furious with the rules. You are taking in all of the sensory information from an environment. Say you're on a scene and you're waiting for something criminal to happen. A car drives by and you see the license plate. So you've attended to the license plate itself. That's what's been selected within your attention. And then within your short-term memory, you're rehearsing the license plate number to yourself over and over and over again to make sure that you keep remembering it. So you're recalling the license plate, no problem. And then that is hopefully stored then into your long-term memory. You're remembering the license plate number because maybe you don't have a pen, you're on foot chase, trying to catch them because they're bad guys and you're a special cop. But later you remember that you need to write the number down or do a fast search and you can figure out whose license plate number it is. So once it's in your, once you've rehearsed it to help you remember it and convert it into your long-term memory, you can then become aware of your desire for that information. So that would again be in your short-term memory stage, and then you can retrieve that information from your long-term memory, and then you can state or use that information of the license plate that you remembered. So just the summary of what we've gone over so far. Memory consists of multiple components. What we're talking about today is the sensory memory, then the short-term memory. Later we'll talk about long-term memory. So these are different stages. They occur in different areas of the brain. They don't act in isolation. They interact with each other. Short-term memory is the process that helps you, that comes before you can store the information. And long-term memory is essential for actually storing that information that you can then use. So let's talk about the first part. There's a lot more to be kind of fleshed out about this. So this idea of sensory memory. We hypothetically are taking in infinite amounts of information. We're taking in all of the information from our environment all of the time, and then are able to pay attention to specific things that we decide we want to pay attention to, or maybe they're just salient enough that you're paying attention. Like when I pulled the thing down the beginning of the day and accidentally pulled it too hard and made a loud noise, you all immediately attended to that, even though you were having conversations. That sound popped into your brain because you heard it, etc. So sensory memory is the retention for a brief period of time of the effects of our entire sensory stimulation. So think about this. There's some examples, one of the examples from your book. So seeing the progression of still images as movement, like right now, you're seeing the light that bounces off of me and hits your eyes, but you know where my hand was initially to where my hand finally ends up, we're perceiving that as one linear, fluid flow of information. So this can especially be simulated or understood when you're seeing like that firecracker, what is it, a sparkler, when somebody pulls it quickly across sort of their body and you're still seeing that trail of that information. That's still like the little residual of that light that's sticking in your sensory memory for a fraction of a second. And the same thing with, you can, maybe it'll help you to even understand it a little bit further when you look at how a camera captures that information. So a camera itself, do we kind of know how cameras work? Cool. I mean, now it's digital, and it's a similar process, but back in the day, you had film, so you had individual frames of film, and then you had a shutter. So what would basically happen to capture the visuals of the scene, the shutter would open for a fraction of a second, typically 24 times per second. So it opened for a second and close, and then move to the next thing. So that would protect the film itself. So it was only in one position and not the movement of that item. But that's how you capture second after second, 24 times per second, sort of that information. And when it's presented to you visually, it seems as though it's fluid motion, even though it's a string of just individual frames. So think kind of your sensory memory, your brief sensory memory of sort of that continuation. There are things that hang around for that fraction of a second. Mm-hmm.
Have we found the top end of what we can perceive yet for frames per second?
For-
Because I know for a while it was, movies were at 24, you can directly see 60, and then at about 120 we stopped being able to perceive anything higher. But now TVs have come out at 240, and you can tell the difference.
Yeah, that's a really good point. that kind of is aligned with some of my research interests as well, because it's difficult to exactly process, like, how can you tell when this is happening so quickly? What a person, experimentally, how can you tell what a person's really perceiving? So a lot of it's going to kind of be, oh, that looks a little different or looks a little weird. And different animals actually perceive things at different rates. Birds perceive a lot quicker than us. So if a bird were to watch a typical movie like we do, 24 frames per second, it would literally just look like flickering pictures. So it's an interesting, there are biological bases for how quickly we can perceive things, and we might even be able to get into that process and make us perceive more, for instance. But I don't think there is a strict, hard rule.
I thought 120 was about a hard rule, but like I said, I mean, the TVs come out and they look that dreamy, weird. I hate that.
That's the interpolation I think we talked about, or some of it occurs from that interpolation. So it's like, instead of real fluid motion, it still simulates. Mm-hmm. So you're still getting kind of that fidgety, like, breaks in motion. It's just doing its best, basically. Or have you ever seen, like, who's seen, like, fantasy shows or movies that are presented in 60 frames per second? I don't know if you've had this experience, I certainly have, where you see it and it just becomes so obvious that it's just people walking around with costumes on. It, like, totally ruins the, like, fantasy, because it really feels more like you're watching real people. It's kind of funny to me. I don't know if you've had that experience too. But, so there were some experiments that kind of got at how long and how much can we really keep in our sensory memory, that really quick, everything from the environment. So this was this is a study that's outlined in your book, 1960, so that was a while ago. People were presented with quickly a flash of an array of letters, so 50 milliseconds, very, very quickly. And then you're asked to report as many letters as possible, so that's not enough time for you to go through and rehearse to yourself, each line of information. So of 12, people were able to report about 4.5 words. So you might conclude that of all of this, we can only remember that amount, that maybe our sensory memory is only able to take in just about 4.5 out of 12 things. But then somebody else came along, or I think further experiments, they were really examining, well, maybe it's not that you can only perceive that much at a time. Maybe within the recall, so even in that process of how long it takes for you to say each letter, maybe you're still, like, you're just forgetting as time goes on, even as you're reciting it to the person. So another experiment, they cued the person to which line to look at. So you still have the brief flash of this array of letters, but the next thing you hear once it ends, you hear either a high tone, a medium tone, or a low tone. So that tells you which line you're going to say. So it's the same image presented to you. You don't know where you're going to be cued yet, but participants were pretty good actually at this test, or this task. So when alerted to which row to look at, they were able to do this 3.3, so that's pretty high out of 4 letters remembered. So that kind of tells you that this entire scene might have been captured pretty accurately or pretty fully. It's just that when you're trying to go through all of this, that even progression of time, affects how much you're able to recite, or the decline of what you're remembering. So then a further experiment, they had, again, the same task of the letters and the cueing high, medium, low tone, but they waited a little bit of time. How much time? It doesn't really say. There was a small delay between the flash of the array and then eventually that tone. And as you would expect, people's ability to recall or to recite the letters became pretty stunted. It was harmed by that. So here's just a graph, and so Here, so on the bottom, it's the tone, so how long after seeing the image were they presented with that tone. And they just did this experiment where it's trying to be clever and tease apart like how long you can actually remember the information from that sensory part. And so the results, what you should take away is basically that the sensory memory is very short-lived. So it's basically a lot of it, potentially all of the world that we're sensing at a time is within that registry, but it decays within a second, so a very short amount of time. So when you're seeing a visual scene, this sensory memory is called iconic memory, or visual icon. The word icon deals with pictures, basically. And it's a similar effect, but I think a little bit longer when you're dealing with the recognition of sound or the remembrance of sound. So there are different effects of modality or mode of sensation of touch or sensation of sight or sound. But the takeaway is that even though it decays really quickly, there's a lot of information that's stored for that fraction of a second. So the function of our sensory memory is basically to collect really quickly and accurately as possible the information that is to be processed later to be used. So it holds this information very briefly for that initial processing, and it's able to fill in the blanks when the stimulation is intermittent. So that kind of gets into when you're quickly scanning over an environment, your vision or that sensory information, sort of like that sparkler, you're still seeing slightly the after effects. If you're scanning a scene very quickly, your mind is going to fill in a lot of the blanks of what you're not paying attention to. So this helps us in a lot of ways just function on a daily basis, so we're not attending to where the door is or when somebody's walking across the scene. It can result in false memories, but basically it gives you that continuation effect. I don't think I'm summarizing that super well, but maybe you get the idea. So what we've covered so far in sensory memory, it has a very large capacity. That's really the takeaway message. Potentially unlimited. It's very difficult to study accurately, but that's what's proposed. But the duration is very short. So the registry of sensory information is that sensory registry. Then we get to short-term memory processes where we're storing that sensory memory for a short amount of time, and eventually the long-term memory, which is the more essential way of storing information for long periods of time. That's it for today. 28. So I'll post this video, and then we will pick up where this left off this Thursday. Let me know if you have specific exam questions. Remember, we curved it. Take a look if you haven't.